Good morning. I hope you guys all are well wake up from yesterday. No reaction? It's okay. So my talk, the title of my talk is The Ubiquitous Language in Functional Programming, and it's kind of crazy idea I had one day about how I could explain functional programming from a different perspective. So this talk is not a course about domain-driven design, and it's also not about functional programming. Well, the thing is, I do expect you guys to understand what I will show. The functional programming part of the talk, I expect you guys to know that. So what I will try to do is to try to show another perspective. So how you can see and understand the data types that we are used to work with from a different perspective. So it's not about teaching monad and functor and so on, but it's about looking to that from a different perspective. So short introduction to myself. My name is Renato Cavalcanti. I work at Lightband on the Lagon team. I'm a founder of the Belgium Scala user group. Very proud to be able to call it a user group because it started as this Belgium Scala enthusiast group. And we were a bunch of guys willing to learn Scala, and today we are a user group, and most of people going to the sessions, they are Scala developers, they're using Scala on their day-to-day work. And by the way, if you got someone wants to give a talk in Belgium, you're more than welcome. I'm also author of ubiquitous, which is very similar to Lagon. And that's not the reason why I'm now at Lightband. It just happened, the other reasons that guide me to that job that I have now. But ubiquitous, it's very similar to the persistence API in Lagon. So Lagon is much more. It's a Microsoft's framework. It offers you much more than ubiquitous. And my email address and Twitter account if you want to reach me later. So the term ubiquitous language comes from that book, and I'm glad that Gideon was talking about that yesterday because then I can skip some part of it. And that seminal book from 2003, written by Eric Evans, titled Domain-Driven Design, Tackling Complexity in the Heart of Software. It's all about how you can model your system, divide your system in pieces that you can easily maintain and make sense of. And there are many techniques to do that. Gideon was talking about bounded context is one very important aspect. I will take another part of the book and I will talk about the ubiquitous language. And what is the ubiquitous language? If you join a project, if you go to work on some place, you have to learn the terms, the idioms of the domain that you have to solve, the problem domain that you are about to build something to solve. So you talk with people that are, for instance, I was once working for building a software manufacturing plant, and I had no idea how it works. And then I learned that they have stations, and you have a start station, and they create a network of stations, and you start a part. It starts on the start station. At that station, it gets a number, and then it moves to another station, and then to another one. And depending on the situation it will move, it will be rejected, and so on. So there are many things that happens with a part, and it goes through that flow over those machines until the end station. So that's all the vocabulary that they use in manufacturing. So when you write software for that, you have to learn that vocabulary. And what Eric Evans was explaining in his book is that very often you go to see a project and you go talk with the domain experts and they talk about station and parts and so on. And then you go look into the code and you see that the developers are, it's not a part, it's an item. Or it's not a station, it's a node, and so on. So they use different terms. And they use different terms because the developer will take the approach of using the terms that he's more used to. So item node maybe is what they would prefer, but that's not what people are using in the field. So the idea of ubiquitous language is to identify that language that should be everywhere, hence the name ubiquitous. And it should be in the human communication, it should be in the documents, in the diagrams. It's the language that is used by the domain experts, and it should be the language used by the developers. It should be in your code, expressed in your code. And then I get this idea of trying to imagine that our task is, as a developer, is to model some basic computations of basic programming language problems. So instead of getting a job to build a software for a manufacturing plant, for instance, you get the task to build a library that has to deal, that should solve problems from day-to-day programming tasks. So let's take a more concrete example about that. Imagine that you are required to model, to create a model to express presence and absence of a value. That's a very common problem. No programming language always have that problem. You go read some value on network or on a file or from memory, doesn't matter, and you may get something or you may get nothing. No? So that's a problem. So that's our first problem domain, okay? That we need to find what is the language and how can I model that? So here's an example. Let's see if this works. Wow. I don't have here a model. So I'm on the JVM, and I know that any object may be null. So it's a knowledge that is in the language itself. So, and it's a problem that I have to solve. I read some value, and it can be null. So I do a null check. I know how to deal with that. I have a solution for that, but I don't have a model here. This is not encoded as a clear type of abstraction. So of course, you guys know where I'm going now. That's the model that models that problem in programming is the option. That type is a modeling from a domain perspective, domain design, domain modeling perspective. The option is modeling absence and presence. So now there are a few interesting things here. The first one is that I communicate that that value can be absent. But what is more important than that is, to my opinion, is that now I have names, I have nouns that is really expressive and explain what is going on. I could have done here, if is defined, I do that, or else I do something else. Or I could have used map and get or else. But I chose to use the pattern matching to explicitly show the nouns of my domain. So when I'm modeling absence and presence, I have some of none. Are those good names for, let's say, the language that we want to let emerge here? Now I'm used to that, but I don't know if they are the best name. I remember when I first saw option, I didn't got what does that mean. I said, what is an option? Well, it's an optional thing. I would prefer that this type was maybe, like in Haskell, because I think it's a better name to say, maybe I get something. It's not like an optional thing. But now I'm used to that. And I'm used to that because I arrive on that new field of functional programming, and like you arrive at a manufacturing plant and you have to learn the terms, I learned that term as well, and now I incorporate that. So now I accept it. But I remember that the first time it was like a weird thing for me. I said, wow, okay, why they didn't call it that then maybe? I have other rants for later. But now And I was talking yesterday that sometimes we create problems and then we have to solve problems later. But that's a very nice problem to create because we create a model and actually we reified the concept of absence and presence to a type. And by doing that, I put it in a box. But now I need to manipulate the value there inside. So you guys know how to do that. I have map. Next slide is a flat map. No new things for you guys. But what is that? What is happening here? I create a data type. I create a box. I put my value in the box. But now I have to solve the problem, how I deal with the value there. And then there is another abstraction. There is another conceptual abstraction, another model that I can add to the option, which is the model of a functor. So the functor models a morphism, a transformation, for whatever that is inside a box. Let's say in a very, very simple way. So the option has this main context that is modeling absence and presence, but by reify it to a type, I need now other kind of abstractions to be able to deal with that. But there is a beauty on that. So we create that problem and we solve it, but we'll solve many other problems because of that. And we'll see in a while. And of course, that option is also a monad because it also has a flat map. I'm being very lossy with the definition of monad here. For me, today, if it has flat map, it's a monad, okay? Which is not true, but for the purpose of this presentation, that will be okay. So I also have this concept of monad that is orthogonal to the concept of absence and presence that the option is modeling, but I also need that other concept. And in the standard libraries, I will not have a type class monad for it, but I have it encoded in the option itself. It's an implementation choice, it has some consequence, but we can work out this without a problem. So what are the phases of an option? Express presence and absence. It has a map and a flat map. It also has those many other methods. But whatever they are, and I pick those three because, well, my next example will also have those three, but there are many others, of course. And most of those types will have this kind of methods, filter, fold, or else, and so on. But they all have, when they operate on the option, they always operate over the concept, the main concept, the main abstraction of option that is presence and absence. And then some funny guy creates a method that randomly, that randomly throws an exception or returns something. And again, I'm on the GVM, and I'm a scary developer, and whenever I call a method, I put in a try-catch block. And of course, the language gives us the way, the means to deal with that. But there is no modeling here. There is no type. This is not reified to something that I can kind of touch. Yeah, you cannot touch things when you're programming, but you can manipulate it, let's say like that. So I don't have that model here. And we know what we're going to do here. We put it on a try. And again, from a domain modeling perspective, that's a very good naming. Because when I pattern match, I have the main type, try, could be attempt, for instance, any name that express what it does, and then the two possible outcomes. They are very, very clear what is going on, success and failure. So it's much better to have code. It's much clearer to have code that where you see nouns expressing what is going on than try and catch. I don't know, guys, if you agree with that, but when I see something like that, for me, it's much more clear. So modeling brings clarity. And without realize all those data types that we use in functional programming, they are modeling some abstraction that are related with day-to-day programming problems. Failure, absence, null pointers, and so on. And again, you know, where we go now, try is also a functor and has its main concept of that try is modeling, but now I also have a box and I have to be able to manipulate it. And it has a flat map. I will not say that it's a monad, but it has a flat map, and so on. And very similar to the option, they have also those methods and many others, but that time, when I apply those methods, I will apply on the context of try. So I will have other types that will look into that, but I took those two because I think it's the most common ones in Scala. And, but now we go back to the beginning. And we see why the functor and the monad concepts, once I have them, why when I create a model and I put something in a box, why I create clarity later on when I start to manipulate them. So the first one, now I have two methods, and it's so terrible to write code like that. I don't know, but that's just ugly. And I have to collect one value, check if it's not a null, and then I go for the second value. And if it's also not null, I do something. And that's even worse. I don't know if you guys see the difference here, but I'm using language constructs of primitives to solve that problem, and they even don't have the same shape. The if and else, I have to nest things, and the try and catch, I don't, because exception interrupts the flow. So I could have nest things, but I don't have to. So the language is giving you the means to deal with that, but each time with a different thing, in a different way. I had an example where you could have where I would do exactly the same kind of code, but then with threads and runnable. If I have two threads and I wait for the result of one, I join with another thread, it's even worse. And then I didn't have a space enough in the slides to put it. So if you're doing that, but asynchronously, it's still another kind of structure that your code will have. And that's the thing. Because now we reify them to types, those concepts to types, and because now I have to solve the problem of manipulating the values that are there inside, I need to have the map and flat map. But now I have a homogeneous way of dealing with all those problems, because they all became the same. At some point, they all become a box that I can map and flat map. I can use the for comprehension, or I can call them using the normal syntax, the method syntax. And the try gives me exactly the same homogeneity in code, and that's for everything. And the example with the future will be exactly the same. And if you take the future, say I will not do asynchronous code calls inside a box like we do with a future, but I will start my threads and pass runnables and join that thread with the other one, and so on and so on. We will have, again, another structure. So all those concepts that we are modeling, they are giving us clarity in code. And for me, when I see that, I remember when I attended my first Scala talk, presentation was in the Java user group in Belgium. And I don't have computer science background. I did something completely different. And so I was not, it was the first time that I ever heard about functional programming. And I was watching that presentation, and I understood nothing. But I understood that there was something there for me. And it was not because I could see how powerful it was. It was simply because I found it beautiful. And when I saw things like that I could deal with null pointers and exceptions, more or less, actually at the same way, that I don't have to do try and catch, if and else, and so on, I just thought, wow, that's something elegant here. And that's why sometimes said, well, I need to give a talk about design and functional programming. And then hence that idea of bring those two words together and talk about the ubiquitous language in functional programming. So what is that ubiquitous language is, what is the domain problem? The domain problem is, the problem domain, is the basic data manipulation problems that we have in our day-to-day life as a programmer. And then we model them to those types. And then we bring all those other concepts, functors and monads and many others, traverse and foldable and so on. And then we create clarity in the code, we create homogeneity in the code. And that's, for me, it's a wonderful thing. But we have some other boxes out there. There are many boxes. And I took here, I will not go in detail on all of them, but I will be more talking about the types and the names that we choose, okay? So the validated from cats, I think it's one of the most clear types out there. So it's like in Scala Z, it's validation. In cat, it's validated. I think it's a better naming, validated, because you call something happened in the past. So it's that thing, it's validated. Open and have a look inside. And you can have a valid and an invalid. That's just clear. That's just perfect. It's also a box here. It's a box without a flat map because it's an applicative, and there are some reasons for not having a flat map. Basically, we want to accumulate things, but I will not go in detail on the validated concept. But validated here is just a name. It could be something else. But the idea is useful to validate things and accumulate errors. So again, a very general problem. I don't know, have you ever done that in Java? Collecting errors? I have seen code doing that, and very often what people have is that they have a list that they pass over, and at each point they add a message on that list. Because everything is mutable, no? So let's do that. That's how people do that in Java. So that's not a real modeling, but validated give you that. And then now is my real rant. Then you have this either type. The option that I would prefer to have maybe, I can live with that. I can also live with that, but I have my complaint is quite different. Let's see what is wrong with either. The type either originally is just about have this or that. A or B, right or left, I don't know, 1 and 2, whatever. It's just about having either one or the other. But, and up to Scala 2.11, it was not biased. But the Scala community has this convention to use either to express an error condition. And that's what this either is doing here. So I define a type error, and I say the left side would be an error, and the other side would be the value the right side would be the value that I'm looking for. But then when I look into the code, if I have just a either, right and left, whatever it could be, it's okay. The name, it's okay. The problem is when I start to consider that the left represents error. That's not the right name for that. So from a domain perspective, that's not the right type to use, because it's not telling you in the codes the correct story. You learn it and you incorporate those concepts, but for me it's always a friction. And because it was very common in the Scala community to use the either to represent error conditions, well, in 2.12, it was decided to make it, in 2.12 it was decided to make it biased on the right side. Before you had to say, I have an either, I don't know what it is, I go to the right side and I do a map, or I go to the left side and I do a map. It was not biased, and you have to make a decision. For me, that was better. That was better to have like that. When you bias it, you make a strange beast. Well, it's not correct what I say. It's not the problem is not it being biased. It's just a decision, a choice. The problem is to use it to express error condition. I think it's not the right type. So, because we are talking about the language and the language that we communicate, I coined this. Actually, the whole idea of this talk is to be able to have a slide with that sentence. A biased either is left. So it's totally absurd sentence, no? So I'm trying to say that a biased either is wrong, but I use the word left for that. So I'm missing the chance to use a modeling that is expressive. And now I force the developers to tweak their brains and accept that left is bad. Maybe for political reasons you find that left is bad if you are so biased politically, but in general, people don't, you have to force their minds to understand that left is bad. Right is right, okay, this one match, but left, that's a bad naming. So this is a non-existent type, okay? But we could have a better type that would be like a neither, but it is a result. It could be validated as well, but validated is not a monad, and so that's why you cannot use that everywhere. So a result, and then you have two branches, a value or an error. This type would be more expressive. John Prairie has, in Raptor, he has another type I should have put here, so how long I still have time. And he has a type, and I think it's called return. And the return can have three possibilities: answer, errata, or unforeseen. And you decide what is the type of the answer, what is the type of the errata, you decide what is your type, and the unforeseen is an unexpected exception. So you call it, and you may have an answer, you may have an error, or you may get something that is unexpected. Then you have three types. I like this one as well. It's a good. I should have put it here as well. So this is about finding a concept, modeling that, but also then finding the right names. And again, John Prairie was talking about this optic. There was a concept that said, well, I have this encoding now, and I don't know how to call it. I will call it optic. Well, that's about finding the name to express a concept, no? So he was talking about that. And someone came to talk with John later and said, well, there is an encoding, and let's call it Larhoven. I'm correct, Larhoven? And the name of the encoding, it exists, it seems, or something similar, and it's called Larhoven. And then I said, oh, please don't call it Larhoven, because then it's really don't express anything. Larhoven is the name of a person, the guy that created the encode, but should not be the name of the type. The name of the type should be expressive. Okay, I'll stop ranting. Another one. That's the Scalatic OR. Who knows Scalatic? Okay, 4 person. Okay, good. So Scalatic is a library that was a spin-off of Scala Test. It was part of Scala Test, and at some point, Bill Wenners decided to make it an apart library. And it has a type very useful to do validation things. And the type is called OR, but it's kind of strange, and compared to the either or other types, is that the left side here is the value that I'm expecting, and the right side is the error. That's a little bit strange, because normally when you do currying, or also when you encode types, you usually choose to take the first type is the most stable one. So here, for instance, I stabilize that all my program use error as an int. So error, I can create now a type that has only one type parameter because the error is already fixed. But there is a reason why it was not done like that. I don't know if you guys know this syntax, but whenever you have a type constructor in Scala with 2 parameters, you can write it like that. That was something that I learned because of Scalatic. I say, wow. And if you have used Scala Z, the disjunction was also using this notation. So you have this V from disjunction, say that or that.
Also tag types and tag types.
Yeah, tagging types also use this trick. And then because of what I guess, I'm sure it was that, is that Bill Veners choose to use the first type as the most, the one that you want, and the right type to be the error condition, because when you use that notation, that just read perfectly. I do some validation, I can get a string or an error, because that's how we talk. That if I talk about coding, I will not say, you can get error or the value you want. No, I will say, you call it and you get the value or an error, because we tend to put it as something that we don't expect or it's not the first thing that we are expecting. So because of that, these types are flipped, and now we have a very clear code. Validation, it can give me string or error, and then when I do a pattern matching, the branch that I have is good and bad. That's just perfect. I love this type. But power comes with lots of fun. I mean, with abuse. And the thing is that those types, they are very powerful, but we should not exaggerate. And I will show some pieces of code. Oh, I still have lots of time. OK, I will rant more. So this is real code that I refactored another day. And it was not exactly like that. I simplified. But the situation is that at some point we had to do a lookup of a URI, and there are 3 possibilities. Well, you remember the thing about the either, that I don't like the way you use that, but I already incorporated it. And when I saw that type, I said to myself, if the error type is a unit, so there is no information, why we are using an either? That was my first reaction, because now my mind is tweaked to think about either like that. But either was being used here in a genuine way. It was really about this or that. And then I saw that comment written above say, left means no lookup is needed, right means lookup was done. And when we do a lookup, we may find a URI or we may find nothing. So the fact that I have this type, and it goes to a companion comment explaining what it is because we missed something here. Because we missed the chance to use a model to express what we are doing. So I was tricked by this either type, and then I went to see the code, and it was like right sum, right whatever, left whatever. And so the idea of ubiquitous language is that the problem that you solve should be expressed in the same words in the code. So if I'm talking with someone about this code, and I say, well, and then the lookup URI was called, and a left was returned. I will never talk like that. I will talk, we did a lookup, but it was not needed. I didn't need a URI. That's the result of the computation of the call. I will never talk, unless you're crazy, you never talk about that problem in terms of right sum, right none, left unit. You don't talk like that. So you should encode the real problem that you're solving. So this code was refactored to that. So we create a type. We create a model to only model that problem. And that was, it's here for conciseness, I keep it simple, but it was private. And this code will never get out of this file. It was living on this file, and it was totally private. And it's not because it's not your main domain that you're solving, like manufacturer plant thing or shopping application or tax cap application. That's the main domain. But inside the main domain, there are many other problems that you have to solve related with programming. And it's totally fine to create those local models that speak a language. So now when I look to that code, I can much easily see what is going on. I pattern match and say not needed, not found, and found. So the code now speaks. And then you get these things here. And really, I have seen lots of code like that. I'm sure you guys as well. Or maybe you have also written code like that. And it's so strange because it's the same as, for me, that is the equivalent of not having any model. We are just using those data structures, those data types, and nest them all together to represent something. It's like using tuples, you know. I do use tuple, but very locally. And as soon as I call something and I get a tuple, I extract the values to names that I can understand. I hate to see, for instance, tuple ._1, ._2, ._3. What is telling that? What is this telling about what is this code? I mean, what is _2? It's nice to be able to do that, but it's much better to just extract them to a variable or to a val immediately when you get it. And sometimes I see code that all methods return tuples, like tuple 3, tuple 4, tuple 5, nested tuples, or nested either in units and options and tries and future and whatever. So there are so many missed opportunities to create clarity by modeling, to look for the concepts that we are trying to solve and put names on that. So this one I will not try to solve because I made up. I don't have a solution. But I'm quite sure that you guys recognize this kind of code. There was one, I was also planning to put it on the slide, but then I thought it was too much. I had a situation that we had to compare two lists and decide that, so I have my original list and I get a new list. And I have to see what are the items that stays the same, what are the items that are being added, and what are the items that are being removed. No? I have to express the delta on those two lists. And then the original code was a mix of low-level ifs and else's and comparisons, and I manipulating those two lists. And it was very hard to follow. And it was also only for list of users, let's say. And then the guy that coded that, he also needs to do the same for a list of employees. So he took that piece of code that was huge and very complicated, and he copy and paste on another place to be able to do the same thing for list of employees. And then say, okay, let's stop a while and let's think about what we are doing. And that was all about emitting events. So I could see, I had to emit events like employee added, employee removed, and so on, or employee updated, so on. That was what I need to get out of that. So I need to compare those two lists and emit events. So at the end, we we came out with a code that was generic. It was a list of A. So I give two lists, and it will compare, and it will give me a sequence that will represent what was happening, like added, removed, not changed, and so on. And then when we were looking to the code, well, the reason that the other reason why I didn't put here is that it was written in Dutch, and I explained why. and so we transformed that code to something that was clear, telling a story. So that's the main idea of having the model, you know. And the reason that it was written in Dutch is that I was working for the Flemish government in Belgium. And we were applying domain-driven design and trying to let the ubiquitous language emerge. And it was an agency from the government dealing with roads. And they have very technical names. So when we go talk with the domain experts, they talk about things like langsgrachten. Like what? How can I translate that to English? And should I translate it to English? Well, that's the domain that I'm dealing with. So the code, all the terms were encoded in Dutch. But the language that we use are encoded in English. It was a Scala. So, and then you have a mix of Scala, of English and Dutch in the code. But there is an interesting observation that we can make from that. When you encode the domain, you're solving a problem. You're trying to encode an abstraction and solving a problem. But you always have to deal with the language, because we are solving that using software. So you always mix our domain with language constructs. And so there is a complexity that is essential to the domain that you're solving, to the problem you're solving, and there is a complexity that is brought in because of software. I don't know who was here last year and when we did a raffle. Who was here when I won a raffle with the software that I wrote? Okay. The funny part is, think about raffle. We had a buggy raffle application, okay? But the idea of raffle, you can write on paper. What is the problem that you're trying to solve? And you can run a raffle in many ways. You can run a raffle just by distributing piece of papers and let everybody put the name and you put in a bag and I pick a name. That's the hardware of that raffle, the means of solving a problem. There are many ways to solve the raffle problem. We solve by using software. So when you see the raffle domain and you see around it the language, language constructs, that is the accidental complexity that is there, because you need to have that. Otherwise, you don't solve the problem. But you have the raffle domain that is encoded, and that should be pure. And when we were looking to our code in the Flemish government, we could see what was domain, because it was in Dutch, and what was accidental complexity because it was in English. The English was the language, it was a Scala, and that was needed, but it was not part of the problem. And that was a nice observation later that we realized, well, when we look here, I can see by identifying the words that are not Dutch and English word, and I can see what is the essential complexity and what is accidental complexity. But it's not true what I'm saying, because there are many words in Dutch that are the same in English. So you kind of get confused from time to time. Okay, takeaways. Data types increase clarity. And we do that. It increases clarity by giving names to things. It's very important to give names to things. And the right name. People often say, what is in a name? Well, there is a lot in a name. Like, a name can be left if you don't choose the right one, okay? There are lots in a name. But the boxes introduce some new concepts, some new problems that we solve with functor, applicative, and monads, and many other foldable traverse, and so on. But you introduce a problem, you create a problem by making a box, and you solve by bringing other abstractions. And you may think, well, now I have this box, and now I have to map before I could just access the value. But because we have them, we create homogeneity in our code. Because now my code is always working around a box of any kind. Each box has its own context, but they all behave more or less the same. And also, don't go too low level when you encode things. Those types are very powerful, but it's not for everything, like the lookup thing. Create your local models and let them speak. And learn FP, so it's about learning those idioms. So in the same way that you go work for a manufacturing plant or whatever, and you have to learn the nouns, the idioms of that domain, when you come to function programming, you learn the names and the idioms of function programming. And what function programming is solving basic computer software data manipulation problems. Absence, failure, validation, the example that I showed, they're all about data manipulation. No, function programming is all about, programming is all about manipulating data. So function programming are putting names on those problems and modeling those problems. Those types are just models. That's it. Thank you very much. I don't know if we have time for questions. Otherwise, we have coffee out there.